Hare Krishna to all the viewers and welcome in this video where today we are going to study the basics of transformer and the EMF equation of transformer. So first let's study about the basics of transformer. First of all, we need to know what is a transformer. How can we define a transformer? So a transformer is a static device which transfers electrical energy from one circuit to another without change in frequency. Okay, so this without change of frequency, this is a very important term. Now what happens here is, suppose there are two things. One is an electrical circuit and then there is a magnetic circuit. So there are two electrical circuits and there is one magnetic circuit. So what happens ki there is one side which is primary and there is another side which is secondary. So these two sides can also be termed as high voltage side or low voltage side. This high voltage or low voltage depends on the number of turns. We will discuss that later. First, what happens that there is an AC supply supplied to the primary side. Now because of the AC supply, because of the voltage, a current will flow. Now due to this current and a flux has been set up here. This flux is phi m and this dotted line is your path of the flux. Okay, so now because of the flux phi m, there is because of self-inductance and EMF will be produced, because according to Faraday's first law of electromagnetic induction, that whenever there is a change in flux, an EMF is induced. So due to that law, due to the self-inductance property, an EMF will be induced. This EMF is E1. So here EMF is induced due to the self-inductance property. In this side, the EMF induced is due to the mutual inductance property. Okay, so here we have self-inductance EMF, here we have mutual inductance EMF. Here also, if we connect a load, then a current I2 will flow. Hence, since a current I2 is flowing through the circuit, we can say that the energy has been transferred. So this is how energy is transferred from the primary side to the secondary side. These are two electrical circuits. In between there is a magnetic circuit. And since it is a stationary device, there is no moving part in this device. That's why there is no change in frequency. Okay, and since this is a stationary device, you can say that it will have a very high efficiency. Okay, we will see the efficiency of transformer in the later classes, and when we will see the efficiency, we will see that it has a very high efficiency as compared to moving or rotating devices. Now let's come to the EMF equation. Now what happens, phi is the flux at any instant. So this phi is equals to phi m sine omega t. Now this E equals to minus d dt of phi t. This equation comes from the Faraday's first and second law and from Lenz's law. This minus sign is due to Lenz's law, because according to Lenz's law, the EMF induced will be opposite in the direction of the actual voltage. Okay, so that's why it is that's why there is a negative sign. So now here t is a constant, so t has been taken out. So now t d phi dt. So now minus t dt of phi m sin omega t. We know phi is equals to phi m sin omega t. So we have just placed the value here. Now if we do the derivation, we will see that dt of sin omega t is cos omega t and omega will be taken out. So that's how we get this equation. From here t omega phi m, this term is the maximum value of induced EMF. So we can replace this t omega phi m with Em, and we can write E is equals to Em sin omega t minus pi by 2. Here also we have done sin omega t minus pi by 2 because cos omega t is there is a negative sign. So in order to remove this negative sign, we have replaced this cos omega t with sin omega t minus pi by 2. If you have studied trigonometry in class 11 and 12, then it will be easy for you to understand. If you have not studied, if you are studying these things in your class 11 or 12, or if you are just studying electrical engineering, then it will be little bit difficult for you to understand, but you can understand it if you know a little bit of mathematics, right? So now RMS means root mean square. So RMS value is equals to Em by root 2. So from here we have just placed the values t omega phi m by root 2. So omega is equals to 2 pi f, which is the value of formula for omega. So we have placed t 2 pi f phi m by root 2. Now this 2 pi by root 2 is 4.44. If you do this calculation in your calculator, you will get the value as 2 pi by root 2 as 4.44. Now E is equals to 4.44 f phi m t. So this is how we can derive the EMF equation of the transformer. Now after deriving this EMF equation, we can also derive the turns ratio. So turns ratio is equals to T1 by T2 equals to E1 by E2. That is also equals to I2 by I1. Okay, so this is the turns ratio. Now after this, there is the construction of the transformer. So transformer construction, there are two types of transformer. One is core type, another one is shell type. Okay, and then there are a few other things, and then there is the equivalent circuit of the transformer and phasor diagram. So for the next class, we will study the equivalent circuit of the transformer and phasor diagram. For now, this is the entire thing of the class. We have studied what is a transformer, what are the different types of transformer, and we have studied the EMF equation of the transformer. Okay, so this is the basics of the transformer and the EMF equation. Thank you for watching this video. Stay safe and be happy. Hare Krishna.